Hello, boys and girls. Welcome to science class. Today we're going to be talking about the three states of matter. So we have solids, liquids, and gases. And we're going to be really focusing in on the atoms that make those three items up. So that's what we're going to be talking about today. What makes a solid, what makes a liquid, and what makes a gas a gas. So you're going to be looking at your packet. In your packet you have these sheets that say like, why does matter matter? And then you're going to be answering these questions here if you haven't already done so. And then also you have what's the matter. Don't you love these titles? So clever. And you're going to be following the directions on that. But I want to go over with you what matter is and what makes a solid, a liquid, and a gas, okay? So first of all, we're going to talk about what is matter. Matter is pretty much anything that we have on this earth. Everything is made up of matter. Within that matter, we have things called atoms, which will make up matter, okay? So with those atoms that we have in those objects, the way that those atoms move determine whether or not those items are a solid, a liquid, or a gas, okay? So for example, if the atoms are very tightly, closely packed together, they have an extremely strong bond, then that item is going to be a solid, okay? Because they're clinging to each other, they have a strong bond, they are making it where it is a solid item. So if you look in your packet, you can see a picture of that. They are very closely tightly packed together. Okay, this is where you can pause the video if you don't have paper and pencil, but if you do, that's awesome. Always try to come when I'm doing a video with some paper and pencil so that you can kind of take notes. But if you don't have one, pause the video and go and get you some paper and pencil. We're going to draw what a solid would look like. So I'm going to draw a square, and I'm going to show you what those atoms are going to look like. So we're going to draw atoms in this square, and we're going to put them close together, and we're going to put them tightly packed because those bonds are going to be very strong. Okay, so we're going to draw. You can start drawing. This is how I'm drawing it. And we're going to put them tightly, closely packed together. That's what's making it a strong bond and making it a solid, because these atoms are not moving. They're solid. Okay, so you can see this would be a solid, how the atoms inside a solid would look. So for example, this glass, those atoms, they are packed tightly together. Okay, they are not moving. You add the right amount of heat to glass though to make you can liquefy it. Or think about an ice cube when you put it in a pan. That solid ice with those water atoms, those atoms, those molecules, they were so tightly packed together. But when you add heat to an item, it makes those bonds break up, and those atoms are going to start to move again, and they're going to start moving around, which is going to make it change states. It would make it go to a liquid, and if you add enough heat, it's going to change it to a gas. So now let's draw what a liquid would look like. Okay, so I'm going to draw another square, and you can draw that on your paper. And I'm going to draw those atoms. They're going to be closer than they would be for a gas, but further away than they would be for a solid. So they're going to be moving, especially because we've added some heat to them some way, okay? And you don't have to apply a ton of heat. For example, I can take the ice cube out of my refrigerator and bring it over here. I've got room temperature in my house, like 70 degrees. The ice is going to start melting because heat is being applied to it. It's going to be hotter out here than it was inside my refrigerator. And we've talked about how water molecules love to cling to a different surface of a different temperature, right? So we've talked about condensation, for example. If it's really, really cold inside your house and it's a humid day like it is today outside, the water molecules may stick to your window pane, correct? So we know that those water molecules and atoms, they love to move and change and stick to different surfaces. So that's how we can go from for example, it's cold in here, hot outside. There's water molecules all in the air outside, water atoms all outside. Water molecules and atoms are outside my house right now with all this water vapor in the air. If I want to change that gas, that water vapor, back to a liquid, well, then I'm going to do the opposite. I'm going to make it colder. Well, my windows are colder right now because inside my house, the air conditioner is running. So that water vapor is going to try to stick to my windows, and that's when we start to see the water droplets form back into a liquid form. Okay, now let's talk about gas. That's when the atoms are moving the fastest of all. They are very fast. Heat is being added to them. And so you can draw that. They're moving quickly. But if I wanted to go from liquid to gas, so here's liquid. If I wanted to go from liquid to gas, I'm going to add heat. I'm going to make those molecules move faster. If I want to go from gas, like water vapor, the humidity outside, that humid air, if I want to go back to a liquid, I'm going to make the item, not hot, what am I writing? Cold. Colder, that looks terrible. Come on, teacher, get it together. There we go, cold. Okay, so that's what you would have to do. To make them move faster, you add heat. To slow them down, you're gonna make it colder. And I kind of think about me. If I'm running and it's warmer outside, I'm usually doing better, right? If it's cold outside and I'm freezing cold, my body just moves a little bit slower, right? That's kind of how it does also with these atoms. That's how I see it. Okay, so first of all, let's go really quickly over solids. I'm going to just read to you what our textbook says. A solid takes up a specific amount of space and has a definite shape. Okay, so this shark is a solid. Okay, it has a definite shape, right? It is not being poured. It can't be poured. It is already created, okay? For example, a book keeps its shape when it is on the shelf or in your hands. A solid also has a volume that stays the same. That means a solid object takes up the amount of space all the time, the same amount of space all the time. Okay, next we have liquids. A liquid has a volume that stays the same, but it can change its shape, okay? So here's my water in this water bottle, okay? It's taking the shape of this container, okay? It still has the same volume, meaning the same amount of water, but the moment I start to pour it into this container, it's going to look different. It's going to look different than it did in my water bottle, but it's still the same amount. It's just taking the shape of this container, okay? A liquid takes the shape of any container it is put into, but 1 cup of water always takes up 1 cup of space in any container. We don't change the amount, we just change the way it looks, okay? And then we also have gases. We know gases are all in the air. There is gas in this bottle now because it's empty. There's gas taking up the shape of this container. There's gases taking up the shape of my room container. Gases are everywhere. They're moving very quickly. The atoms, the molecules, they're moving very quickly. You may know that gas takes the shape of its container. A gas does not have a definite shape or a definite volume. It takes up all the space in its container. The air in your classroom is a gas. It takes the shape of your classroom. It also takes up all the space inside the classroom. If you put the same amount of air into a larger classroom, the air would spread out and take up the space in the room because those atoms and molecules, they really like to move, right? So that's a little bit about the 3 sets of matter. I'm going to put a video in the comments, so I want you to watch the video. I think you'll like it. And also, I'm going to upload a brain pop in the video in the comments as well. If you've created that brain pop account, it's a free account. I put instructions on the Facebook page on how you can go in and create that free brain pop account, and then you can watch Moby and is it Max and Moby, I think, on the brain pop and watch the video And there's also some quizzes on matter if you would like to take those. I hope you enjoyed science class today, and I hope you all are having a great Wednesday. I hope to see you soon. Bye.